Today we begin with the new chapter number 12, electricity. Very important for the students, those who are going for the science in 11th and 12th. Now see, electricity has an important place in modern society. It is controllable and convenient form of energy for a variety of uses in home, school, etc., hospital, everywhere electricity is used, and it is a convenient, rather very important word is this, that it is a convenient source of energy. You can just plug in and put the appliance on. Okay, so it's very convenient to use. Okay, how does it flow? What constitutes the electricity? How does it flow? What is electric current? What are the factors that control or regulate the current through an electric circuit? How the current is regulated in the circuit? How can we control it? Or rather, more current should not pass. For that, what should be done? Okay. So in this chapter, we are going to study and answer all these questions. We are going to study the heating effect also, and how the heat is produced in the different electrical appliances. Okay, now see, first of all, electric current and circuit. First, very small topic. Okay, we are familiar with the air current and water current. When the water is in motion, we say it is water current. Air is in motion, then it is air current. Okay, we know that flowing water constitute the water current in the river. Similarly, if electric charges are in motion or they are flowing in the conductor, or we can say in a metal wire, then we can say that the electric current is passing through the conductor. So, flow of electric charges. Flow of electric charges is the flow of electric current, and the current can pass through the conductors only, that you know. Bad conductors like rubber, wood, they will not pass the electric current through it. Okay, now see, we say that electric current is flowing whenever the electric charges are passing through the conductor. In a torch, we know that the cells or a battery, okay, they provide flow of charges or an electric current through the torch bulb to glow. So when we put the cells in the torch and we put the circuit on, or we put on the switch, put the switch on, then we say that, or we see that the bulb glows and the current is passing, and that current is because of the presence of the cell. Okay, we have also seen that the torch gives light only when the switch is on. What does a switch do? Okay, the switch makes a conducting link between the cell and the bulb. Now see, if you have this, say, bulb, okay, and you have, say, this is the cell. Now this is the positive terminal, as this part is called. Now if there is no connection between this bulb and the cell, then you will not have the bulb which is glowing. Okay, so there must be some connection here, and that connection is provided by the switch, and because of that device, that is switch, the bulb can be made on as well as off. Okay, we have also seen that the torch gives light only when the switch is on. What does a switch do? Switch makes a conducting link between the cell and the bulb. A continuous and closed path of an electric current is called the electric circuit. Okay, what is electric circuit? Please underline this. Okay, the continuous and closed path of an electric current is called the electric circuit. Okay, so now if you consider that, say for example, you have this cell, okay, and wires are taken from that positive part, or that part which is slightly up, okay, and it is connected with the bulb. Okay, and if you join it with the metal part of the cell, then This is a closed path, okay, where the electric current is flowing or it can flow. This closed path is nothing but the electric circuit, okay. Now if the circuit is broken, say for example if you are breaking this circuit somewhere here, or wire is broken, okay, see here, then what will happen, the current will now stop, okay, the bulb will not glow. If you join this again, then and then the bulb will start glowing. Or if you say, if you are breaking it here, okay, then what will happen, this glowing will stop or the bulb will not be on, okay. So if you want to on the bulb, there must be a connection between the positive and negative terminal, with in between what is there is a bulb or a device which you want to keep on. Now if the circuit is broken anywhere, the current stops flowing and the bulb does not glow. How do we express electric current? Now how can we show that what is the amount of current, or how can you measure the electric current? Now see, simple example I am taking it for you. Say for example you have a tube. This is a pipe, okay, and water is flowing. What is there? Water. Now you are taking the water from this end. You have a bucket, and in 1 minute, say for example you are having 10 liter of water. So the flow of this water can be said that it is 10 liter per minute. So amount of water upon time, 10 liter per minute, or we can write also 10 divided by 60 seconds, so 1 by 6 liter per second. 1 by 6 liter per second, we can say 1 by 6 liter per second. So amount of particular thing, in how much time it flow, amount of particular substance, whatever it may be, that is flowing, okay, that amount per unit time, that is called the current in general. In general, when you say that current I want to express, then what is the expression? Amount of particular quantity which is flowing divided by time interval in which the quantity is gathered, okay, or we can say amount of quantity per second, okay, amount of quantity which is flowing per second is nothing but the current of that particular quantity. Now here when we talk about the electric current, what is flowing? The charge is flowing. So amount of charge flowing through the conductor in 1 second. So we can say amount of charge flowing from conductor in 1 second. That amount of charge flowing from conductor in 1 second, or amount of charge flowing per second through a conductor, is nothing but the electric current, okay. So electric current can be defined as rate of flow of electric charge. It is rate of flow of electric charge. How much charge flows in 1 second, okay. In circuits using metallic wires, electrons constitute the flow of charges. As you know, the flow of charges is nothing but the flow of electrons. However, electrons were not known at the time when the phenomena of electricity was first discovered. Okay, electric current was discovered earlier, but what or which particle is constituting the electric current, it was not known. Electrons were discovered after the discovery of electric current, okay. So which charges are constituting the electric current was not known, but charges are there. Charges were there, they were knowing, but electrons were flowing, they were not knowing that. So electric current was considered to be the flow of positive charge. It was earlier believed that positive charges are flowing and they are the responsible charges for the flow of electric current. But as you know, nowadays, બધાને ખબર જ છે, as you all know, that electric charges, that is positive charges, are found to be in nucleus, and the electrons which are there in the different orbits. And in metal, the outermost orbit is having 1, 2 or 3 electrons. Try to understand. Sodium is having 1 electron, magnesium is having 2 electrons in the outermost orbit, and aluminum is having 3 electrons in the outermost orbit. So this outermost orbit electron will be coming out from the orbit, not from the metal. It will remain within the metal, and this electron is responsible for the flow of electric current. Try to understand. If you have some metal piece, okay, say for example you have a metal piece, okay, for example you have a metal piece, okay, you take the metal piece this way, okay, and these are the metal atoms. I'm just showing 4 here to make you clear. Now these are the nucleus as such. Now in the outermost orbit, say this is aluminum metal, so there will be 3 electrons. Outermost orbit only I am showing. How many electrons are there? 3 electrons are there. Okay. Okay. So there are 3 electrons in the outermost. Now these electrons will come out of the orbit and they will be moving randomly in the metal. They will be moving randomly in the metal. So these electrons which are coming within the metal, not outside the metal, try to understand. These electrons will not come out of the metal, they will reside within the metal and they will move in a random direction. So any metal you take, say this is your positively charged nucleus, then outermost orbits are giving the electrons in the metal, and these electrons are randomly moving in any direction. So they are not as such constituting the electric current if you do not join any battery or a cell. But when you join any cell here, say for example this is the cell which you are joining, so what will happen? These electrons will have a particular force exerted on it and they will start moving in one particular direction. Okay, and because of the motion of these electrons in one particular direction, then the net amount of charge will pass through the conductor and that will constitute the electric current. Earlier, some electrons were going in this direction, some were going in the other direction, this were going the other direction, the other one. So no net charge was crossing the cross section or the metal piece. No net charge was crossing the cross section of the metal piece. But when you apply this battery or a cell, then these electrons are experiencing the force and they will start moving from one point to the other in one particular direction. But before the discovery of electron, it was considered to be the flow of positive ions or positive charge was flowing. Okay, so if you consider the battery whose positive terminal and this is the negative terminal, which are shown as such by the, say this is positive charge which is there, okay, this way the battery is shown, this is positive terminal and negative terminal. Earlier the flow of charge was nothing but it was considered to be the flow of positive charge. So electric current was shown from positive terminal and it was moving towards negative terminal from battery. The charges were taking energy. This battery is a source of energy. Try to understand. Okay, so the charges were getting energy and again they were started moving in the circuit. Okay, say for example you have a bulb here. Here, say we put a bulb. So bulb was say glowing, okay, and the energy was spent, okay, and then again they get the energy from the energy source, that is cell, and again they will move in the circuit, okay. So positive charges were believed to move in the circuit, but after the discovery of electrons, they found that it is not the positive charge, but the electrons are moving, and positive charges were taken to be moving from positive terminal of the battery to the negative terminal of the battery. This is positive terminal, and it was believed that the positive charges are moving from positive to negative terminal. Now electrons were discovered and found that they were, or rather they are moving from negative terminal of battery to the positive terminal. So when we say that electric current is flowing from positive terminal of the battery, that is a conventional current which was a kind of tradition to show, but electrons are moving in opposite direction of the conventional current, so electrons will be moving in opposite direction, that is from negative terminal to the positive terminal of the battery. So up till now it is clear that it is flow of electric charge which is constituting electric current. Second, the rate of flow of electric charge, how much charge is flowing in 1 second or charge per unit time, is called the electric current, that is rate of flow of electric charge. Okay. Now electric current was considered to be the flow of positive charges, and the direction of flow of positive charges was taken to be the direction of electric current. Okay, so direction of electric current was direction of flow of electric charge, that is positive charge. Okay, so it is here. So electric current was considered to be the flow of positive charge, and the direction of flow of positive charge was taken to be the direction of electric current. Conventionally in the electric circuit, the direction of the electric current is taken as opposite to the direction of the flow of electrons, because it is the negative charges which are responsible for the flow of electric current. Okay, so electrons are moving in the opposite direction of conventional direction of electric current. If net amount of charge, say charge which is flowing is Q amount of charge is flowing, so amount of charge is Q in time interval of T. In time T, we can say in time T, charge Q is flowing through any cross section of the conductor. Okay, so this you consider as a conductor, and through this cross section, say Q amount of charge is flowing in time T. So charge upon time, that is Q upon T, gives you electric current. That was explained by me when I took the example of water flow. Amount of water, say amount of water is 5 liter in say 10 seconds, then we can say 5 upon 10, that is 1 by 2 liter in 1 second, we can say. Similarly, amount of charge is taken to be say Q in how much time T. So Q upon T, amount of something which is flowing divided by the time interval, gives you rate of flow of that particular quantity. The SI unit of electric charge is coulomb. Try to understand. The unit of charge is coulomb and unit of time is second. So the unit of electric current will be coulomb per second. It is in the memory of scientist Ampere, this coulomb per second unit, this unit which is nothing but coulomb per second, is taken as ampere. So we say 5 ampere current is flowing, 15 ampere current is flowing. We have different circuits in our house also for 5 ampere, 10 ampere, 15 ampere currents. Okay. Now see, we have one fact. Try to understand this, that the charge of one electron, समझो, charge of one electron is minus 1.6 into 10 to the power minus 19 coulomb. This much amount of charge is associated with one electron. It is negative, so we have written minus. One proton, that is also having the same charge, but it is positive charge, 1.6 into 10 to the power minus 19 coulomb. So what is the charge of one electron? It is minus 1.6. What does minus show? Minus shows the nature of the charge. It is negative charge. That is why we have taken minus. Okay. Now, say for example, if you have 1 ampere current. 1 ampere means what? 1 coulomb per second current is flowing. Now, try to understand this particular calculation. Now see, if you have 1.6 into 10 to the power minus 19 coulomb charge, if you have this much charge, how much charge? 1.6 into 10 to the power minus 19 coulomb. Then you have, say, 1 electron. If you have 1 coulomb charge, then how many electrons will be there? Now, nature of the charge is negative. Just now I am not writing negative here in front of 1.6 into 10 raised to minus 19. So you can just calculate. These are multiplied. So 1 divided by 1.6 to 10 raised to minus 19. And this will result in 6.25 into 10 to the power 18 electrons. So we can say that if you have 1 coulomb charge, then there are 6.25 into 10 to the power 18 electrons. So we can say when 1 ampere current is flowing, it means 1 coulomb per second charge is flowing. It means that 6.25 into 10 raised to 18 electrons are flowing in 1 second through a cross section of the conductor. Say for example, this is the conductor, and if you consider this as a cross sectional area, then through this cross sectional area in 1 second, how much charge will flow? 6.25 into 10 raised to 18 electrons will flow. Okay. Now if you have 5 ampere current, okay, 5 ampere means 5 coulomb per second. It means 5 into 6.25 into 10 to the power 18 electrons, that is 31.25 into 10 to the power 18 electrons will be flowing if 5 ampere current is flowing. Similarly 15 you can find. Okay. So 1 coulomb charge means how many electrons? 6.25 into 10 raised to 18 electrons. Okay. So this is the, what you call it, some of the understanding, basic understanding. This current is having the unit 1 ampere. Okay, current is having the unit ampere. And when can we say 1 ampere current is passing? That I explained. 1 ampere current means 1 ampere means 1 coulomb charge is passing in 1 second. Then we can say 1 ampere current is flowing. Okay. Now 1 ampere means 1 coulomb per second. Just it is written here. Okay. Small quantities of current are expressed in milliampere and microampere. 1 milliampere, 1 microampere. Milli means 10 raised to minus 3 ampere. When I say that 5 milliampere current is flowing, say 5 milliampere current is flowing, it means that 5 into 10 to the power minus 3 ampere is flowing. Okay, milli means 1 milliampere is equal to 10 to the power minus 3 ampere. Similarly, microampere. 1 microampere is 10 to the power minus 6 ampere. So when I say 10 microampere current is flowing, we can say 10 into 10 to the power minus 6 ampere. Okay, so these are the smaller units, microampere, milliampere. Okay, small amount of currents are measured by using this particular unit. Okay, so this is all about today's lecture. Okay, just go through it. 1 microampere, 1 milliampere, everything is given. This is a simple circuit which is shown here, which I tried to explain to you. Okay, there is a battery, or there is a combination of different cells. There is a key, or we can say switch. This A stands for ammeter. It measures the electric current. Okay, it is connected always in series in the circuit. In one line it is joined this way. Okay, that is a connection which is called a series connection. In one line everything is joined, then it is a series connection. Okay, so the ammeter, this is the ammeter. Ammeter, what does it do? It measures electric current. It is always joined in series in the circuit. Okay, and this is the bulb. Now what is the amount of electric current that is flowing, that can be measured with the help of this ammeter? Okay, and from that how much charge is flowing, that can be known to you. Okay, so this is a very simple circuit which is shown here. Okay, here a very small sum is given. Okay, 0.5 ampere current is flowing in how much time? 10 minutes. What is to be asked? શું કરવાનું છે? ચાર્જ ગણવાનો છે. Q is equal to I into T, because I is equal to Q upon T. So charge Q is equal to I into T. I is 0.5, time is 10 minutes, so 600 seconds. So just you have to multiply 0.5 into 600 will give you 300 coulomb charge. Okay, thank you very much.